Hello friends and welcome to YouTube channel Freedom Tech. And in this session what we are going to learn? In this session we are going to detect, track and create a counter for object which basically moving on conveyor belt. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, today we are going to create a counter with the help of YOLO V8. We are going to detect our object, then we are going to track object, then we are going to create a counter for object which is basically moving on conveyor belt. For that, simply we are going to use here YOLO V8 object detection method. So simply first just open Python IDE and we are going to install our basic packages. So open Python IDE, go to the tools, manage packages and search for opencv-python, hit enter. First package, click on install button and then it will install OpenCV on our Windows 11 machine. This is Windows 11 machine. Of course you can use here Windows 10 machine also. Then we need Ultralytics package. So search for Ultralytics package, hit enter. First package, click on install button, it will install Ultralytics on our Windows machine. Then we need CV zone package, hit enter. First package, click on install button, that's it, it will install CV zone also on our Windows machine. So this is how we need to install opencv-python, then Ultralytics and then CV zone package for this project. So I have create here a new repository. I will mention the link inside description box. You need to simply copy paste the link inside your web browser. So what is our repository name? YOLO V8 conveyor belt object detection, tracking and counting. So just go to the code, click on download zip and it will download our zip format repository. As you can see, it's now downloading. So friends, we have done with downloading our repository. Just open file manager, go to the downloads and this is what our repository. Right click, WinRAR, click on extract as a folder name, just click on it and it will extract our folder. Again same folder, and first we need our video file. So vid.txt, just open as a text editor, copy the link, copy it, close editor and open your browser, open the new tab and press Ctrl+V. It will copy paste the mega cloud link where I have shared the video file for this project. And as you can see, this is what our basically video file and we have here mineral water bottles packages which basically moving on our conveyor belt. So this is what our video. So let's just get download our video. Click on download and our video is now downloading. So friends, as you can see, we successfully download our video. So let me close the mega cloud link and if you go hit download package.mp4, just cut the video file and move the video file inside same repository over here. So let's just start our video file. So friends, as you can see, there is a packages which basically moving on conveyor belt. This is the mineral water bottle packages, as you can see, which basically moving on conveyor belt, and our goal is to detect these packages and track all those packages and then assign the ID, and then with the help of ID we are going to create a counter for these packages. Simple. So for that, simply first we need images. So here inside a repository I have already create a database with labels. So there is no need to create the database with label img software, because for this project I have already mentioned the images with their labels. So images.zip, this is the zip format file. Just right click, WinRAR and extract as a images folder. So if you open images folder, again we have same images folder and then here it is. As you can see, we have packages.txt file. Inside that we have rectangle coordinate which I have draw with the help of label img. So we have here basically text file and their images also. As you can see, images.jpg format images. So each file it has their txt file. Inside that txt file we have rectangle coordinates. So we have done with label img side. So simply what we want here now, simply we are going to create a freedomtech.zip file, but first we are going to create freedomtech folder. So right click, new folder, and mention the name freedomtech, there is E. So create a name folder which is freedomtech, and then just open again freedomtech folder, and here again we are going to create a two new folder, images and labels. So right click, new, images, and the next one is labels. That's it. We create a two new folder inside freedomtech folder, images and labels. Now again go inside images folder, and here we are going to create two new folder, training and validation. So right click, new, training, and then create a validation folder, again new one. That's it. So training and validation folder which we create inside images folder. So same way go to the labels folder, and here also again create a two new folder, training and validation. Training, let me cross check. Yes, now it's perfect. Training, and then new folder, validation. Yes, training and validation. That's it. Now simply what we want to do, we want to move our images data, all the data from images to freedomtech images training validation, from images to freedomtech labels training validation. So let's just press Ctrl+A, copy all the data, copy it, go back, go to the freedomtech folder, images, validation, just paste it data, go back, training, paste it data, go back, then go to the labels folder, validation folder, paste it all the data, go back, training folder, paste it all the data. So this is how we need to simply copy paste all the data from our images folder to freedomtech to images training and validation, from freedomtech to labels training and validation. That's it, we have done. Now simply we are going to create our freedomtech as a freedomtech.zip file. So winrar, add to archive.zip, click on OK. It will create a freedomtech.zip format file. Now we are going to simply move our file on our Google Drive. So this is what my Google Drive. You need to open your Google Drive, go to the new file, upload your repository which is YOLO V8 conveyor belt, again same freedomtech.zip, and it will upload our freedomtech.zip file on our Google Drive. Meanwhile we are going to upload our Google Colab file. So click on upload, browse, go to the repository, and this is what our Colab file, first one, click on open, and it will upload our Colab file on our Google Colab. So friends, as you can see, we successfully upload our Google Colab file. Now here go to the runtime, change runtime type, select Python 3 and select T4 GPU, click on save button, and then click on connect button. It will connect our Colab file. So friends, as you can see, we successfully connected. Now we are going to run our cell one by one. So let's just start. First cell, done. Now next cell, it will install latest Ultralytics package on our Google Colab machine. So friends, we have successfully run our second cell where we install pp install Ultralytics package. So then we are going to simply run our next cell, from Ultralytics import YOLO, from IPython display import display and image. And now we are going to cross check if we successfully install Ultralytics on our Google Colab machine. For that we are going to cross check with YOLO V8n.pt pre-trained object detection model. We have image which is doc.jpg from roboflow.com, and with the help of this model YOLO V8n.pt we are going to cross check our object. So for this image we have one car, we have one person, and we have one dog. It means we successfully install Ultralytics. Now we are going to mount our Google Drive on our Google Colab machine. So just click on the next cell, connect to Google Drive, select your Gmail ID which you use for uploading your freedomtech.zip file. Then click on continue, scroll down, click on continue, done. Now it will mount our Google Drive on our Google Colab machine. So friends, as you can see, we successfully mount our Google Drive, and here we have our freedomtech.zip file. Now let's just unzip the file. So first we are going to create dataset folder, and inside that folder we are going to unzip our freedomtech.zip. So just click on next cell. That's it, we successfully unzip our file freedomtech.zip. Now just click on this small folder icon. We have dataset folder, and inside that we have freedomtech folder and images and labels. So here for freedomtech, just click on these three dots and click on new file and create the new file. Mention the name data.yaml. Data.yaml, just hit enter. It will create empty data.yaml. Just double click on data.yaml, and now just open our repository, downloads, our repository, again same folder, and inside that I have mentioned data.txt file. So from this text file just copy all the text as it is and open the browser, and here in data.yml just paste the text which we have copied from our data.txt file. Just copy paste, and here mention the name which we are going to train. So our class name is for this project basically package. So mention package, and number of classes is only one because we are going to detect only one class, and our class name is package. Done. Just press Ctrl+S and save our data.yaml file. We have done. Now we are ready. We are going to create our own custom object detection model with 100 epochs. Now let's just start our custom training. So friends, as you can see, our process is started, 1 out of 100 epoch. So it will take some time. Meanwhile, I will pause the video. So friends, we have completed our training process, and our model is saved inside runs, detect and train folder. So just go to the runs, detect, then we have train folder, and then we have weights folder, and inside that we have base.pt, our own model. So just click on this three dot, click on download, and our model will be downloaded. So friends, as you can see, we successfully download our model. So let's just minimize all these things, open file manager, downloads, and base.pt. Just right click, click on the cut and move our model inside our repository, just paste it over here. We have done. Now we are going to open our main 1.py code with the help of our Thony Python IDE. That's it, we successfully open. So this is what our Thony Python ID. I have mentioned here already our base.pt model, and then vid.mp4, and now we only want to create here coco1.txt, our label file. So just new and create a text document, mention the name which is coco1, and then open it the file as a text editor and mention our class name package. This is what our class name, package. Save it, close it. Now we have done, because I have already mentioned full code as a object detection, also as a tracker. Here it is, as you can see, this is what our object detection method, and then we are going to send the object detected coordinates, the rectangle coordinates. With the help of list, we are going to send this coordinate to our tracker. Here it is, as you can see. If you watch my previous videos, then you definitely know how we use our tracker. For tracker, we want to send our object detected rectangle coordinates. So here we create a list dot append, and we append our object detected rectangle coordinates x1, y1, x2, y2, and then we are going to call our tracker file, because inside repository I have mentioned the tracker file also. Here it is, as you can see, tracker.py. So for tracker, we are sending our detected object coordinates, rectangle coordinates. Here it is, as you can see, we mention here list dot append, and here I have mentioned the list. Inside this list, we are appending all our rectangle coordinates. Then for bbox, in bbox id, again our tracker will be basically track object, and it will assign the id for each object. So again we want to mention here new rectangle coordinates, so x3, y3, x4, y4, and the id, which is new variable, and bbox, this bbox. Then we need a center point. So center point is basically cx and cy. So int x3 plus x4 divided by 2, cy is equal to int y3 plus y4 divided by 2. This is how we will get our center point. And then we are going to draw our rectangle. Then we are going to put id as a text on our each detected object rectangle. So this is how we are going to detect our object. With the help of tracker, we are going to assign the id for each object. Done. Now if I start the code, there is something missing. Let me check here. vid.mp4 is the file name. Oh, the video file name is a package.mp4. Let me change the video file name. It is package.mp4. Okay, so mention the name package.mp4, not vid.mp4. Now it will start our code. And as you can see, friends, we have here our detection. Also each package we have id. For this package we have 1 is the id, because our tracker is basically tracking this package. Then this package we have 0 is the id. Then this package we have 2 is the id. So here in this area, basically we can say the id is not changing. The id is not changing. So we are going to track our package. Let me now pause the video file, or we can say simply mention here 0. Now we can simply skip our frame one by one. Just press the space button from our keyboard. So here it is, as you can see, we can simply move our frame one by one. So here it is, as you can see, when this package is moving, it has same id. It has same id. So we are going to create here somewhere here. Let me start again with first frame. Here we want to mention our region of interest area, and then when the center point of this detected object, if it is inside our mention area, then we are going to detect our object. Simple. So for that, first we simply want to mention here a cv2.circle method. So let's just mention cv2.circle, and inside that we want to mention a frame, because we want to draw our circle on our frame. Then what else we want? We want cx and cy, this cx and cy. Then we want to mention a radius, so let's just say 4, and the color, let's make it blue 25500, and then -1 is basically because we want to fill our circle, so mention the -1. Now there is a center point, as you can see, for this object, for this package we have blue color center point. So now, as I mentioned, we want to draw our region of interest area. For that we have here mouse event function. Here it is, as you can see, mouse event function. When we move our mouse cursor on the frame, we have inside shell we have xy coordinates. So let's just say I just want to start from here. So for this point we have coordinate which is 488 300, 488 300. So let's just mention the coordinates here, 488 300. This is what our first coordinate. Then let's just say over here 479398, 479398, 479398. This is what our second coordinate. And then let's just say over here 607417, 607417. This is what our third coordinate. And the last one is basically come over here 609288, 609488. Now we have four coordinates of xy. So this one is first xy coordinate, this one is second xy coordinate mentioned in the bracket, this one is third xy coordinate, and the last one which is the fourth one xy coordinate. And mention all these coordinates as in square bracket, and mention as a area is equal to these coordinates. Now with the help of cv2.polyline method we are going to draw our area over here. Mention it, cv2.polylines method. We are going to draw our polyline on the frame, and then we are going to mention like this way np dot array, and inside that we are going to mention our area coordinates, and then we are going to mention here int 32, and then we are going to mention true, and then we need to mention here our polyline color. So let's just say 2550 pink color, and the thickness let's just say 2. That's it. np.array area 1 int 32 true, and the color and the thickness. Save the code, and if I run the code, int 32, just a minute friend, here it's like this way np.int 32, and just a minute, this coordinate is basically come over. So this coordinate will be come over here. So if I cross check, it is 609297. So 609297, I have mentioned here 488. That's why the polyline is wrong. So no worry, just cross check, because we have mouse event function, so we can cross check our coordinates and we can simply mention perfect coordinates. Now as you can see, it's good. So this is what in the pink color, this is what our region of interest area. So if our object center point, if it is inside our area, then only we are going to detect our object, then only we are going to track our object. This is the method which we already use in several previous video for creating a counter. So same method, that's it. So now what we are going to do here, as I mentioned, for this we are going to use cv2.pointPolygon_test method. So here, after where we have cx and cy coordinates, just mention result variable. Result is equal to cv2.point p capital polygon t capital point polygon test. And as I mentioned, for point polygon test we need our area. So our area is basically this, from np.array to np.int32. Copy as it is and mention this cv2.polygon test method. Here I have mentioned a bracket, so just paste it, and then when this center point if it is inside our area. So we mention our area. Now we want to mention this cx and cy, object center point. So mention as a tuple cx and cy, and then mention false. And now if the result, if it is greater than or is equal to 0, then only we are going to draw a circle, then only we are going to draw a rectangle, then only we are going to put id as a text. If I save the code, if I run the code, now as you can see, there is no detection in other area. Only if this package come inside our selected area, then only we have blue color rectangle, sorry, not blue color rectangle, then we have green color rectangle, blue color center point, and then we have id. So if you skip the frame one by one, when this package go outside of our area, now there is nothing, there is no detection, there is no center point, there is no id. Now watch for this package. When this package come inside our area, our selected area, as you can see, there is a detection, there is a green color rectangle, there is a blue color center point, and there is a id. Now simply we can create a counter, because we know that if our id it is inside our area, then we are going to save the id as a list format. So here this is what our condition. After that, simply we are going to mention list1 dot append, list1 dot append, and what we are going to append? We are going to append our id, and here we are going to mention list 1 is equal to empty list. It will append our id inside list 1 when object if it is inside our area, because we create here a condition. Now of course, if it is inside our area, if our object if it is inside our area, then of course we have the id, because we have our tracker. Now if you just print over here, let's just first print our id, sorry, not id, list 1, because this is what our list. So list has the length function, so mention our length function, length list, and just start the code. Now as you can see here, this object if it is inside our area, we have here basically the print id. Let me mention like this way, just a minute. First we are not going to mention here as a length, let's just mention list 1, sorry, my bad, the list 1 is basically our id. I have mentioned here list, this list variable, not this list variable, because this list is basically for our rectangle coordinates. We create a list 1 variable, so let's just mention list 1, and if I save the code, if I run the code, now as you can see here, this is the id. For this object we have 4 id, as you can see we have 4 id, but it continuously showing us a same id again and again, because this same id is particular time if it is inside our area, it will again and again assign the same id, means it will again and again same package count again and again. For that we are going to simply mention here, please don't count same package id again and again. So for that, here let's just mention our condition, if list1 dot count, list1 dot count, what we are going to count here? We are going to count here our id count is equal to 0, means please don't count same id again and again. Then we are going to mention list dot append. Now it will count one package only once time. Just skip the frame. As you can see, we have 4, so it's counting one package only once time, because we have 4 id only once. That's it. So now simply we are ready, and this we are going to create as a variable. Mention counter is equal to the length of our list one. Let me mention like this way, length of our list one, and then we are going to use our CV zone put text method, and we are going to put our counter on our frame. So here same way, and then the id we are going to mention our counter variable. So mention here counter variable, and then we are going to put counter as a text on our frame, and then we are going to mention the coordinates for frame 50, 60, and let's just say 2 as a rectangle size, 2 as a text size. Now save the code, and if I run the code, now as you can see we have here counter, and we count here one package. So just skip the frame, we count one package. Done. Now the next package is basically coming inside our selected area. If it is inside our area, there is a id, and we count two package, second package. So this is how, friends, with the help of YOLO V8 we create our own custom object detection model. Then we track our packages, and then we basically assign the id for each package, and then we create a counter. Simple. So let's just start a while loop. So 0 as a 1, save the code and run the code. Now we started a while loop, we count one package, there is id. Now we cross our area, the next package is coming, it's detected, there is a id, and we count two packages. So this is how, friends, we can create our own custom object detection model. Then we assign the id with the help of our tracker, and that's it. This is for today. We will meet our next video. Till then, thank you, take care, and bye bye.